How many of y'all know what a lightning rod is? What's a lightning rod?
A lightning rod is this big metal pole.
Uh-huh. What's it for?
Oh, it's for electricity.
What type of electricity? Lightning. What a lightning rod really is, a lightning rod is to help you discharge the gas that's surrounding your building, which is what plasma? Anybody remember that? The charged gas that surrounds that. Remember what Eric told you about how lightning occurs. Let's say this is a cloud, okay? If this were a cloud, okay, and the turbulent air caused the charges to separate and the nucleus to go up here, your atom that's minus an electron, to move up there, and all your electrons to move to the bottom. So this cloud now has a net negative charge on the bottom of it. So it's looking for the path of least resistance, which is the ground. And when the charge from the ground begins to rise and the charge from this begins to go to meet it, when both those charges meet, that's when you get lightning. So what is thunder? Well, what happens is that lightning produces so much heat that it heats up the air around it. And that begins to make the air expand out, and that's the pop that you hear. So why do you see the lightning before you hear the thunder?
Because in order for you to hear the thunder, the lightning has to occur to build up the energy to make it pop.
Well, close. That's exactly right. Yes. Light travels much faster than sound, about 1 million times faster than sound. So if the lightning were to strike you, how much difference would there be between when you heard the thunder and when you felt the lightning? None. Because it's happening at the same time. You're not a distance away from the lightning. So you don't have to wait for the sound to catch up. So what we're going to do is show you essentially a lightning storm. And what you'll see with this is you're going to see the bolt of electricity fly out to hit this. That's the lightning. That little snap that you hear every time that goes off, what is that? The thunder. And y'all hear it instantly. Why? There's no difference between when the lightning is striking and when the thunder. Why? Because you're right next to it. There is no difference in the time between when the lightning strikes, you see the lightning, and when you hear the thunder. It doesn't have to travel any distance. You're right next to it and you'll hear it. So let's get ready to shock myself again. All right. Let's crank this guy up a little bit more. I was kind of hoping for a continuous. I think the humidity is keeping us from being able to get a good discharge. Let's stop this for a second and see. Okay. We're actually going to hold this. Okay, Miss Dunn, I need your help. I want you to stand over there and point that nail. When I tell you to, point it at the dome. Not till I tell you to. The pointy end.
Yeah, if you don't mind.
The pointy end. And not till I tell you to. Let's try this one more time. Because it might just be too humid inside the building to get a good constant charge. You know what I might do? paper towels. Okay. Let's give it another shot. Okay. Point at it. Point at it, Miss Ricaldi. Point at it. Get a little closer. Oh, there we go. Now take your hand down. Take your hand down. Point at it again. A little closer. That's good. Oh, no, no. Okay. Okay, step away from it. Step away from it. Yep. So, what did the lightning rod do? Yeah, well, it drew the charge away from the dome so that you didn't get the lightning strike into the building. Now, that's the main purpose of a lightning rod. The purpose isn't really to attract the lightning, it's to discharge the area around the lightning. But if it does strike, if the lightning does strike the building, what else does that lightning rod do? It gives it a path where? To the ground.
Good guesses.
This is an extremely high voltage, 700,000 volts. That's a lot. But it's at a very low current. Remember what we said current was? Which direction and how much. So there's not a lot of current flowing through me. There's a lot of voltage, but there's really not a lot of electricity when you think about it because the current's real low. Think about it as if it were the Mississippi River right now. Okay? The Mississippi River right now is flowing really fast because all that snow from up north is melting. You go out there, you jump in it, you're going to be a mile down before you know it. That's a lot of current. That's a lot of power. That's a lot of water with a lot of current. If I were to go into the lake on a nice sunny summer morning, it's nice and calm and it looks like glass. You can jump in it, not going to hurt you. Massive amount of water, a lot of power, no current. It's pretty much the same thing. There's no current actually flowing through it.